Download this code from codegive.com, link in the description below. Knowledge distillation in machine learning. Knowledge distillation is a technique in machine learning where a smaller, more efficient model, often called the student, is trained to replicate the behavior of a larger, more complex model, the teacher. This is particularly useful in scenarios where deploying large models in production is impractical due to resource constraints. Why use knowledge distillation? 1. Efficiency. Smaller models require less memory and compute resources, making them faster and easier to deploy. 2. Performance. The student model can often achieve performance comparable to the teacher model while being significantly smaller. 3. Practicality. Facilitates the deployment of models on edge devices with limited computational power. How does knowledge distillation work? The basic idea is to transfer the knowledge from the teacher model to the student model. This is typically done by 1. Training the teacher model on the training dataset and obtaining its predictions, soft targets. 2. Using these soft targets as labels for training the student model. 3. The student model is trained using a combination of the true labels and the soft targets. The soft targets can provide more information than the hard labels, as they include the probabilities of the different classes. Steps for knowledge distillation. 1. Train a teacher model. 2. Generate soft labels from the teacher model. 3. Train a student model using both the original labels and the soft labels. Code example, knowledge distillation with PyTorch. In this example, we'll demonstrate knowledge distillation using PyTorch. Step 1, Setup. First, install PyTorch if you haven't done so. Step 2, Import libraries. Step 3, Define teacher and student models. We'll create a simple convolutional neural network, CNN, for the teacher and a smaller CNN for the student. Step 4, Prepare data. For simplicity, we will use the SAFAR 10 dataset. Step 5, Train the teacher model. Step 6, Generate soft targets. After training the teacher model, we can generate predictions, soft targets, for the training data. Step 7, Train the student model with soft targets. Now, we will train the student model using both the original labels and the soft targets. Step 8, Evaluate the student model. Finally, we evaluate the student model to see how well it performs. Conclusion. Knowledge distillation is a powerful technique for transferring knowledge from a larger model to a smaller one, allowing for efficient deployment of high-performing models in resource-constrained environments. In this tutorial, we demonstrated how to implement knowledge distillation using PyTorch, providing a practical code example to illustrate the concepts. By using soft targets generated from a teacher model, the student model can achieve competitive performance while being lighter and faster.